Buongiorno, sono qui per presentarvi la nuova edizione di Trieste Next. Il titolo della 14ª edizione di Trieste Next è La vita dentro, dialoghi tra scienze e tecnologie. 3 giorni per riflettere su come la scienza e la tecnologia ridefiniscono la vita, su come le discipline STEM dialogano con le scienze umane e su quali nuove domande emergono per il nostro futuro. Medicina di precisione, intelligenza artificiale, sostenibilità ambientale, robotica, biotecnologie e tecnologie quantistiche sono solo alcuni dei temi al centro di Trieste Next. È questo il fil rouge del festival, con un programma di oltre 100 eventi in inglese e italiano e oltre 300 relatori di fama internazionale. E ancora, il premio Trieste Next Science Book of the Year, le 70 attività per le scuole e i 40 spazi espositivi e laboratori aperti a tutti in Piazza Unità. Prima di accogliere gli ospiti del prossimo evento, a nome dei promotori e copromotori della manifestazione, vorrei ringraziare tutte le istituzioni scientifiche di Trieste, città della conoscenza, e le istituzioni che hanno collaborato con noi, il main partner del festival, i partner e i content partner della manifestazione per il contributo fondamentale. Grazie anche ai media partner e ai partner tecnici. Infine, un grazie speciale ai 200 volontari di questa edizione. Ricordatevi anche di controllare il programma aggiornato degli eventi su www.triestenext.it, al quale potete accedere anche da questo codice QR. Buon ascolto e buon festival!
Hi everyone. Working. Hi everyone. Nice to meet all of you. I'm Federico Morosato, a researcher from the Centro Protesi Inail of Budrio. And I will present you two of our research projects that are still ongoing on osteointegration and amputation. So the combination between biological process and surgical technique also that exists since decades, and prosthetics for amputation. So let's start with a brief introduction about what is Centro Protesi Inail. So Centro Protesi Inail is part of Inail, so the National Institute for Insurance for People Injured at Work. And in particular, Centro Protesi of Budrio is under central direction of prosthesis assistance and rehabilitation. We cover all the national territory. Our headquarters is located in Budrio, in the Bologna city, but we have also two branches, one in Rome, one in Lamezia Terme, so in the south, plus a rehabilitation center in Volterra, Tuscany, and a series of assistance points so as to cover all the national territory. What we do is to allow people with impaired injuries to go back to work after the injury. In particular, we are specialized in manufacturing and developing of custom-made solutions, prosthetics and orthotics for people that lose an hand or with a specific mobility impairment. Plus, we have a series of services that we can erogate, like psychosocial support, rehabilitation. So we work together with the healthcare system, national system, and vehicle adaptation. But our main focus is the production and manufacturing of custom-made prostheses and orthoses manufactured on the morphology, on the anatomy of the patient who comes to us for a service. Plus, we work also with sport for production of sport prosthesis and aids. So we work with the Paralympic athletes, some Paralympic and national athletes, supporting them with the production of sport prosthesis. Among these activities that are the main activities, there is also the research group. I'm part of the research team that is composed of 19 engineers. 5 engineers are dedicated to applied research, so more linked to production. 14 are more linked to basic research, and I'm part of this last group, this bigger group. And over years, we started collaboration for a lot of research projects with different national and international institutes, universities, hospitals, and created over time, years by years, a huge network with specialized institutes. So in case we have a research project about neurosciences, we work with a specific partner, IET of Genoa, Sant'Anna di Pisa, so a lot of excellence institute to work with us. And the research projects that are 19 ongoing now, are funded by Inail, that works as a supervisor, but also we have, let's say, technical engineers that work actively in the development of products. These are the research lines, so robotic rehabilitation, lower limb and upper limb prosthetics, surgery and rehabilitation, and assessment system. Let's start with the focus of today, osteointegration. Osteointegration is a biological principle phenomena that is well known. The first osteointegrated implants exist since the 60s and were made for dental implants, dental reconstruction. So screws inserted in the bone and used as a connection from the inside to outside with a tooth, in case of tooth replacements. These specific osteointegrated implants are evolved then in the arthroplasty, so endoprosthesis. You probably know people with the joint replacement for like hips joint, knee joint, or shoulder. These are osteointegrated implants that are inside the body. We work more similar to the dental implants that are transcutaneous. So part of it is fixed in the bone inside our body and part is exposed. And the exposed part acts as a connector with the prosthesis. Osteointegrated implants for people with amputation, let's say, were first used at the beginning of the new millennium, so are quite recent, but their diffusion is still not so spread so wide. What's the necessity of it? Well, let's start with a brief history about the classics, the traditional prosthesis, the so-called socket-type prosthesis. Normally, prosthesis, so the robotic part, is connected to the residual part of the body, also called as stump, through socket. That is an hollow object in which the stump is inserted and act as a connector, a rigid connector between the body portion, and the prosthesis. For example, in case of lower limb, upper limb, and digits, these are circled here in red. In case of digits, this is not properly called a socket. But the concept is similar, is a connection, a rigid connection that link the portion of the prosthesis that can move to the hand, in this case, to a rigid part, and create a stable connection between the moving part and the residual part of the body. There are lots of good things to say about sockets. For example, they can be used by all people. There is a simple technology, widely diffused. We can work on material, but the principle about socket, behind the socket is, let's say, almost the same since years and years and years. And it's good, but there are some limits. For example, skin irritation. The perfect fit between the stump and the socket is guaranteed at the time you produce the socket. but over time, the stump can vary. For example, volume variation can make a stump bigger or smaller. In this case, you risk to lose the perfect fit with the socket with problem of stability. This also can cause friction between the socket and the skin, causing irritation. This can be complicated in case of disease of the, like vascular disease that reduced sensibility in the peripheral part of the body. You can't perceive the friction and the irritation with risk of ulcers if the friction continues, especially for lower limb, if you walk a lot. And the other point is the proprioception. Proprioception is the capability that we have to perceive our part of the body in the space without seeing the part of the body moving. I'm talking to you now, but I well know that I'm shaking my hand because our body is full of sensors that communicate with our brain and say, okay, you are moving something, and I'm moving the hand up and down. These sensors are most of the time present in muscle, tendons, but in case of limb loss, you will lose this kind of capability. And the transmission, the low transmission, is guaranteed by the connection of the socket with the skin. And the skin is not full of sensors like this. So the proprioception is lost or sensibly reduced. Osteointegrated implants have this series of pros and cons. Among the pros is the list on the left. Of course, no need of stump socket because you are replacing the socket with an implanted fixture inside the bone. You have a fast connection, and I invite you to come to our booth in the main square with some example of devices, of osteointegrated devices. You can see with your eyes the easy way to fix, to connect and disconnect prosthesis to the implant, to the fixture, to the metallic fixture. You get a correct load distribution because your load passes through the mechanical connection from the prosthesis directly to the bone. Differently with the socket, as I mentioned before, the load is transmitted via skin and soft tissue. So it's not correct with problems like the one I mentioned before. Better stability, so you don't have the risk to lose the prosthesis because it's rigidly fixed to the bone. So there are no problem. The issues about the volume variation of the stump can be not considered. The stimulation, the direct stimulation of the bone increase over time bone quality and favor the bone remodeling. You know, it's well known that unloaded bone over time reduces density and may cause year after year problem of osteoporosis or osteopenia or osteoporosis. With a direct connection, you stimulate continuously the bone because the load directly reaches it. And this physiologically imply bone cell proliferation and an increase in bone quality, overall bone quality. And the osteoperception, so the capability of perceive your body, so the perception via the bone. Bone presents a series in a portion called periosteum, a series of mechanoceptors that act as piezoelectric materials that when stretched with a deformation convert this mechanical signal into electric signal. It comes to the brain and we can perceive it that the load is the bone is loaded. This, for example, is very important when I walk with a prosthesis. I can perceive what if I'm stumbling or if I'm walking on grass or so let's say soft ground or hard ground. About the cons, here a small list. So eligibility criteria. While, as I mentioned before, socket, let's say, is almost available for everyone. In case of implant fixation, you have to start with a good quality bone. For example, when you do a hip arthroplasty, a knee arthroplasty, shoulder, the surgeon needs to make a good check of the quality of your bone before implantation. There are some cases in which the quality of bone is not sufficient for allowing the implantation of a fixture like this. The surgical intervention that is necessary, and some people don't want to go under surgery. risk of infection, because we are talking about a transcutaneous implant. So you have an interface between in and out. And this interface is a risk of, the risk of infection in the interface is higher, of course, than a stump socket, than a socket type prosthesis. Of course, there are procedures to minimize the risk of infection, but is an aspect that must be taken into consideration when performing such an intervention. And excessive loads forbidden. This is a particular aspect because there's not enough literature that allow you to say, okay, with an implanted fixture like that, you can do what you want. So in order to be safer, normally we ask people not to do sports activities. Or in case they want to do sports activities or activities that may generate excessive loads in the bone, there are some tricks that we developed to bypass the osteoimplant, the osteointegrated implant, and return to use a socket type prosthesis. But if you want, we can go in deep with it in the question time. I mentioned the osteoperception, so the perception through bone. This is just the definition. So the ability to discriminate between different loads through mechanoreceptors located in the bone and also known as sensation through the bone. It's just a summary of what I mentioned before. And we consider this aspect fundamental for prosthesis embodiment. Embodiment is the identification of the prosthesis as part of their own body. It's very important aspect that prevent prosthesis abandonment. A lot of people, in particular that wear socket type prosthesis, don't feel the prosthesis like part of their own body. They reject the prosthesis. They prefer not to wear it because of any different problems. The socket issues that I mentioned before, the device that is not the correct device for you, and we need to intercept your needs and provide you the correct orthosis or prosthesis in order to get an embodiment. Among the factors, we consider osteoperception and the capability to restore the proprioception through osteoperception, one of the fundamental aspects and factor towards embodiment, prosthesis embodiment. So let's start more in deep with the research project. We have two ongoing research projects, one osteocustom, that is osteointegrated implants for transfemoral amputation, so in case of above knee amputation, and a joint that is in case of thumb amputation. Okay. Do osteointegrated implants exist? Yeah. The first osteointegrated implants arrived in the market 15 years ago, more or less, and there are different companies producing it, but they're still not diffused because of thousands of problems, and particularly first because they are not known from patients that have an amputation. And also because of the people sometimes don't want to be implanted permanently with a fixture like that. And second, and at the end also because the geometry of this kind of commercial implants is sometimes not suitable for your specific geometry. They are they follow the concept of arthroplasty implants for arthroplasty. They have fixed geometry with different sizes. This is the concept in the market for osteointegrated implants. Like the hip, you have a hip with a certain shape and different sizes. The same is for implants, like for people with amputation. So you have like a cylinder stem with different sizes. But our anatomy is not cylindrical. Our medullary channel is not cylindrical. All of us is made with a certain anatomy. And plus, Centro Protesi Inail manufacture custom-made prostheses. So we take the possibility we have to produce custom-made prostheses and transpose them into the world of osteointegrated implants in order to produce custom-made osteointegrated implants. This was the basis of our project. So the idea in the basis of our project, try to make a custom-made osteointegrated implant. So let's start doing a comparison. Commercial implants versus custom-made implants. So both they require a tomography of your femur in case of all over limb. This what I say can be used for any anatomical district. For let's consider a bone, a femur. They need both a CT of the anatomical site for bone segmentation. Then the surgeon select the proper size based on your anatomy. In our case, we have an exact size that fits only you and your specific anatomy. And then you buy the prosthesis, so you get the different sizes. Normally, surgeons receive the size of the prosthesis they selected for you, plus one size and minus one size. In this way, in the surgical room, in case you have any issues, so let's say they have the option B. And in our cases, we produce just one prosthesis, multiple copy if necessary, but just one prosthesis, because we know that that implant is suitable for you and only for you. And then you need the surgical operation. So there are no big differences. It seems there are no big differences between the two concepts. So why custom made? Well, there are some interesting possibility that custom made device guarantees. Let's start seeing the picture. Let's start seeing the picture. So normally in the medullar channel of a femur is not straight. It has a curvature. It has not a specific circular section. So it has a geometry that is not regular. And even after regularization, that is a normal procedure that is done in the surgical room, there are some irregularities due to the natural curvature they have. So in case of a commercial stem, the contact that is required for having osteointegration is not always guaranteed. In case of custom-made devices, well, yes, of course, because it's made based on your anatomy. So, which are the good points for having a custom-made device? It can increase the patient suitable for implants. We know most patients want the socket-type prosthesis, but people that want osteointegrated implants can have a better implants because the implant is made on your specific anatomy. So it can increase the number of patients that can undergo this kind of treatment. Plus, bone preservation. Bone preservation is fundamental. When you have to prepare in surgical room the bone, you have to, let's say, dig a bit, ream the internal medullar channel of the femur here with specific surgical tools in order to regularize the bone. In case of a custom-made implant, this regularization is less invasive. You can preserve bone because you start with an implant that is ready for the implantation, and the regularization is minimally done. You get a better contact surface for load distribution between bone and prosthesis, and is a favor is good for osteointegration, for allowing bone cell proliferating on the implant. And this is the last point that is good for our research project. Through the additive manufacturing, I didn't mention it before, but our idea is to use additive manufacturing of titanium powder. Titanium alloy powder. We can create the shape we want, or better, the external shape is the custom-made shape. But internally, we can think to do, for example, spots for cable passages, or in order to sensorize from the inside the prosthesis. This is just a spoiler of a new research project that you are opening now, or they'll say at the beginning. But maybe next year, if I'm still here, or my colleague can present you some advancement in this direction. So let's start going deep with the projects. So osteocustom, osteointegrated implants for transfemoral amputation. We have time. In order to produce a custom-made device that can be given to patients, it must follow a series, especially implantable devices that are class 3 devices for medical device regulation. You have to do a lot of tests to be compliant to norms and regulations. But the starting point is every time the site segmentation. So as I mentioned before, you need a CT scan of the femur, a segmentation of the femur, and we develop also a statistical shape modeling algorithm starting from a huge database of segmentations, of segmented femurs, to check which are the parameters that can be used for our purposes. And implemented a software that, starting from a CT scan of a patient, extract the segmentation, and do the segmentation, and create the model based on curvature. The important parameter are the curvature and the section. So based on these two parameters, the software is able to do a first draft, let's say, a model, a mock-up of the final implant. Then there can be a refinement done by the orthopedic technician, but this is ready to be printed. And together with it, we also developed the bone rasp. This is called bone rasp. It's a surgical tool that is required by the surgeon to better prepare the implantation site. And then you have let's say the most time-consuming part. So design and manufacturing. And this is the part in which you need to be compliant with regulation and norms. So we conduct years and years of tests. For example, this technique, it was not possible in Italy. So we also work with the surgeons to create a procedure, starting from already existing procedure, but to refine a procedure in order to be suitable for a custom-made device. So we work in cadaver lab in order to define the technique for implantation, and then cytotoxicity test, stress test to understand which are the allowable load for this kind of implants based on the ISO norms, finite element analysis, so a lot of tests, and at the end, eventually we did it. We produced our first titanium alloy made implants with a specific geometry for a specific patient. And also the rasp. The implant is made in additive manufacturing. The rasp is made as traditionally made in CNC machine. And then implantation. So I decided to skip all the bloody images from the surgical room. So it's just a model to present how intervention is made. So preparation of the bone, implantation of the stem, connectors. Let's say now just connectors that are transcutaneous, and this is how it comes out from the surgical intervention. At the base of the connectors, there's the prosthesis. So you lose the stump, the hollow object to put in touch with the stump. You lose the socket, and you have just a metallic fixture coming out from your skin. And this is what we did. So these are on the left, the fixture that is implanted in the femur, the abutment, this is just a connector, and a safety system. We have developed also a safety system that act as a mechanical fuse. It's like the electrical fuse. In case of excessive current, an electrical fuse break and prevent damages of the device that is attached to it. This is a mechanical fuse. So in case of excessive loads reach the prosthesis, reach the implant, this safety system has some fuse inside that breaks and prevent that excessive loads reach the implant. Especially in this case, this is a safety system for torsional loads, because torsional fracture, in case of torsional fractures, let's say the period for rehabilitation, restoration, remodeling of the bone is very complex. So it's better to avoid any kind of fracture, and in particular, a torsional fracture. That's why the existence of safety system. There are also safety systems for bending, but there can be safety system of every kind of loads. This is just for torsion, and this is made by us. And then the clinical part. This is the most maybe this is the most time-consuming part, not just the compliance with regulation. So we start conducting, in accordance with a medical device regulation, a series of clinical trials. The first, Metacos, with a small number, a pilot trial with a small number of patients and commercial implants, and then is ongoing osteocustom that is a pivotal trial with a larger number of patients. And we have also in preparation the pilot trial with the osteocustom system, so our system. That is at the booth, so if you want to see it directly, you can go there. Okay, and this is the outcome. First outcome, most important, 2023, osteointegrated implants became an accessible service in the national territory, entire national territory, especially in Emilia-Romagna. So people with an amputation can decide to go with this kind of intervention, and is covered by the national system. This is only in Emilia-Romagna because we were the first. Our idea is to create the basis in order to have a diffusion of this possibility in the rest of the regions. In the rest of the regions, we were just the first doing it together with Istituto Ortopedico Rizzoli. Maybe you know it, is an excellence in arthroplasty located in Bologna. And this is one of our patients with osteointegrated implants. As you can see, let's say the symmetry of the gait is, I would say, perfectly restored. Left and having some motion analysis, so you visibly see, but you can visibly see through your eyes in this video that the load symmetry is perfect, and also the gait parameters are, let's say, equivalent between the right and the left leg. Adjoint, so our second project is about the production of custom-made device for thumb amputation. As for osteocustom, we did a series of tests and segmentation, of course, so segmentation of the bone cavity, production of the model, and this is how it happens. So in osteocustom is just to create a stable connection between a rigid thumb prosthesis, but it does not restore the phalanx articulation. You need to have a metacarpal phalanx articulation good. So it's just a bridge in between this portion of the bone of the finger and the fingertip and the thumb. That is rigid, is not in motion. We did a lot of tests. As before, this is another cadaver lab in which we developed the surgical technique, how to do it, what to do, what not to do. Mechanical tests, a series of mechanical tests, analysis of the porosity of the surface, the quality of the production in additive, and also FEM analysis plus other analysis. This is just a brief summary. And implantation. And this is the final output. So as you can see, you have just a thumb with a small metallic fixture coming out from it. The alternative for this kind of amputation were two. Just a brace of the prosthesis, a brace of the prosthesis in some part of your hand, so like a ring that is connected to your wrist, to your hand, or in some portion of the base of the thumb, and some metallic connection, external metallic connection to the fingertip, or glue. Some people that have without a thumb just have an aesthetic thumb made in silicone, very good to see, but that is stick with a glue that every day must be, let's say, used and put on to be a not functional thumb. So alternatives are very low. That's why we're moving towards this direction. In this case, you have a connection to a prosthetic thumb from the inside of the body. And this is what we give. So the fixture, as for osteocustom, is a custom-made fixture in additive manufacturing in titanium alloy, and it's a screw. It's not press-fitted. The abutment, that is the connector, with the thumb with a high grip tip, fingertip, and a soft interface. The thumb is 3D printed. It's in PLA, I think. It is in plastic made. And can be of different colors, design. We work a lot with designers for having good products, and not just functional product, but also good products, aesthetically good products. We are still conducting clinical trials. We have some ongoing trials with the first pilots. for people, and we are working on the pilot for long fingers. This was all just for the thumb. We are redesigning the thumb, but we are also working on the long fingers. The design is pretty the same. That's why we move easily towards long fingers. And these are the outcomes. So through the restoration of the thumb, so the opposition of thumb, you can do lots of stuff that you couldn't do before. So for example, looking on the right, you are able to write again with your, let's say, natural strategy for writing. And also, this man in the middle could work in his garden. So for a second, let's consider that this is not safe for infection problems. We try to convince our people to use gloves and give instruction how to use our devices. In this case, it decided to use directly without any protection, but nothing happened, fortunately. We are now developing some protection to use in case people want to use without a glove this kind of prosthetic thumb. But as you can see, he was able to do his garden works as his nature, if he has a natural thumb. So to summarize, well, I was very fast, so we have time for questions. To summarize, there are two categories of prostheses. Let's say type of prostheses. The traditional prostheses, that are the socket-based prostheses, and the osteointegrated implants. Implant fixture, so osteointegrated implants and sockets are the connection in between the body and the prosthesis. The difference is the presence or the absence of the socket. I already told you that lots of patients can access to a socket-type prosthesis. This is not so true for osteointegrated implants, but people that can access osteointegrated implants can have, with our products, we think, a better product, a custom-made product based on your specific bone morphology. So it's not a versus, but we consider it's an and. So it's a second option people can have. Normally, differently, people can only have socket-type prosthesis. With osteointegrated implants, we create a new possibility for people that ask us to have this kind of service and treatment. So it's a plus. And this is the final motivational sentence. This is not, it's something that my colleague at the booth wanted to insert. It's not for motivational sentences, but it's nice. So the idea is not to put what we did, because we have an expertise as Centro Protesi Inail of traditional prosthesis, socket-type prosthesis. We exist since the 60s of last century, and we manufactured and produced socket-type prosthesis for decades. The idea is not to take what we did, the technology achievement we get, and put it in the bin, but to start from it and create new possibilities for our patients. That's why I was forced to use this sentence at the end of my presentation. So we don't want to waste the past, but use it to see the future. And thank you for your attention. Hope to be clear, because was it clear? More or less. Okay, 36 minutes. We have 30 minutes for questions. A lot, if you need it. First, my suggestion is to come and visit our booth, because there are a lot of nice stuff to see and touch. Adjoint, Osteocustom, both the projects are present at the booth. We have also a project about osteointegration of the humerus for in case of above elbow amputation. But okay, let's visit our booth and you will see. I'm here for any question. I mentioned before the possibility to do sports with an osteointegrated implants. So I told you that we should avoid excessive loads, right? So how to do sports? Well, our idea was to create a protection for osteointegrated implants and a modified socket-type prosthesis. So the implant is protected by soft part, on top of it, you can use again as once a socket type prosthesis. So effectively, you are walking or doing sports with a socket type prosthesis, but the socket is not just the connection with the body, but also a protection for the implant that comes out from the bone. So in case, for example, we have a person that do snowboard with an osteointegrated implant. He wants to do snowboard, so we produced a special socket type prosthesis for him. So as when he does not sport, snowboard in particular, he can walk with his osteointegrated implants. When he do sports, he, for example, goes at the gym, so do lots of sports, he can cover the osteointegrated implants and go back and with the prosthesis and start using again the socket type prosthesis. In this way, you can use both the solutions and switch in between one and the other, depending on the context, depending on the activities you want to do. It wants to do. This is a good, a nice solution with it. There are some company in Europe that produced osteointegrated implants. All these kind of implants are made as the one I told before. So fixed geometry with different sizes. That's why we wanted to move in this direction, but with a different strategy, a different context. The other thing to say is about cost, because of course, custom-made implants have different cost than implants with a fixed geometry and scalable size. But Inail is not a company. As a cost, we have no margins on the product we manufacture. So we just produce devices with a certain production cost, and this is the cost for the system. So there's no problem. If I buy a prosthesis from a company, you pay not just the manufacturing cost, you pay the manufacturing cost plus the margins. So that can be 10 times the production cost. So eventually our costs are lower than the cost of a prosthesis bought by a private company. This is an advantage that we have as a public institution. We cannot do profit, but we can work on the cost reduction. That's all. So any questions? I have a question for you. Did you know the osteointegrated implants for amputation before today? No? No? That's why they exist since the beginning of 2000, but nobody knows about it because they're not so diffuse. Even patients with amputation don't know the possibility to have an osteointegrated implants. Don't know why. There are not many states, many countries in which this is an available option for the healthcare system. In Germany, for sure. North Europe in general. South Europe, I think just Italy, maybe France, but I'm not sure. But it's not so known. That's why we need to work on it in this direction. Yeah, a question.
How do you approach the problem with infections?
Yeah, thank you for the question. Well, the first approach is instruction for the patients. So we give patients a list of rules, let's say guidelines to follow. Normally, patient with a socket type prosthesis must follow some guidelines that consist in the monitoring 2 times and controlling 2 times per day the stump. Just check if any ulcers, any wounds appeared. The same approach is must be done in case of osteointegrated implants. So 2 times per day, morning and in the evening, you have to check specifically around the wound, the interface in between the in and the out, and check if it hurts, and or granules, or let's say tissue that is not the correct one you are expecting. You have to, there's a manual for how to apply correct hygiene in the wound, and stop. Normally, water and soap is sufficient. In case of infection, the patient must contact directly to us immediately to his medical doctor for the treatment of the infection. We didn't have problems of infection so far. The guy working in the garden had a problem at the beginning that was treated immediately, and now he know how to use it. So it's just it's simply you need to cover it. So let's say everything we do is a trade-off in between our consciousness and the rules. So what we can do is to instruct patients, give him a new possibility, but at one point you say, okay, you know how to do it, do it. We have responsibilities. We have responsibilities, of course, but until a certain point. After this point, the responsibility comes to the patient. The most important part about this, the treatment of infection, but is a more higher rule, general rule, is the eligibility criteria. You have to select the correct patients. Eligibility criteria include also psychological analysis, because we know about patients that were treated in a way that was not proper for him because of some psychological disorders, and it was a disaster. So the idea is to identify patients that are good for this kind of treatment. We know in advance, or at least we hope through this analysis that in advance that these are suitable for this kind of treatment. They know the risk, they are instructed, and then after the selection, they do the implantation and the rest of the procedures. But at one point, the responsibility comes to the patients. Well, we cannot go further in this. There are no way to control the patient every day of the year.
Thank you for your stimulating presentation, first of all. I want to ask you to explain more about the psychological assessment for people who decide to do a prothetic implantation.
Well, I'm not a psychologist, but as I mentioned before, as a Centro Protesi, we have different activities inside. We have a group of psychologists that are, let's say, devoted to this kind of analysis. Technically, I don't know what they do, in which way they test it, which are the tools, the instrument, the report, the self-report, the questionnaire they do, sincerely speaking. I don't know. I don't think that the classic mini mental test is enough to make it eligible or not. But for sure, there's a psychological analysis at the beginning. For the details, I don't know. I can ask to my colleague from psychology department, and I can give you any answer if you want to text me to write me an email. But I know that this part is fundamental. Sorry, but
I was curious about, like, do you perform the whole pipeline from design to implantation, or there are some parts where you delegate to someone else?
Yeah, of course. As a research project, we have a big group of engineers from mechanical, electronic, informatics, biomedical, designers, so physiotherapists, orthopedic technicians that works in the research group. But for example, we don't have surgeons. For surgery operation, we work together with the Istituto Ortopedico Rizzoli, that is an excellent in arthroplasty, and now is working also in this direction of osteointegrated transcutaneous implants. For the production, we have, despite we have a huge number of additive manufacturing machines, but we print only plastic-like material or silicone materials. For the production of titanium alloy-based material implants, we do it in outsourcing. outside. There are companies that are specialized in laser melting technique for additive manufacturing of materials, of metallic materials, that are certified for medical device. That's the one point. You can do a lot of stuff, but in the medical field, there are very strict regulations. So in case of especially additive manufacturing of implantable devices, you need to be a company dedicated to 3D printed metallic fixture. And to get this certification, you need to work a lot. This is, let's say, not a business for the research. Sometimes we can produce it internally, sometimes, like in this case, which is a very complex case for manufacturing. It's better to do these tasks to people that do it for work. That is its job. We have also rehabilitation, physiotherapists. So also the rehabilitation part is done internally. And after the rehabilitation, the person are followed by Centro Protesi for the thumb, which is produced by us, and from the surgeon, from his personal medical doctor, and also the surgeon for any TAC assessment, CT assessment, or yes, imaging, or if you have to check the quality of the fixture of the implantation, you directly talk with your surgeon.
Sorry, is there an age limit for this kind of operation? And the age limit, like 60 years old, or for the osteoporosis, osteopenia?
Well, it depends on the quality of your bone. Normally, it's done a quality check of the bone mineral density, and the surgeon has the responsibility to say you are eligible for it or not. There are no limits about aging. Normally, even in arthroplasty, there are no limits. It depends on the will of the surgeon, and some of the most important factor is your age, just because of your health status. For example, if you are not available for anesthesia, some people, the old people, for example, are excluded not just because the bone, but because there are other pathologies or comorbidities that make you not eligible for anesthesia that is necessary in this case, like in case of hip or knee. So there are other conditions that make you not eligible. The age is not directly linked to this, is not a direct factor. Is what is correlated to your age that represents a key factor. Osteoporosis, the possibility to sustain anesthesia, so and other factors. But potentially everyone is eligible. Well, see, another point, this is interesting because some in healthcare system, for example, this is no because my grandmother needed a knee, and some surgeons said, okay, you are too old for it because it's a very expensive, it's bad to say, but it's a very expensive treatment. And as you are 93 years old, it's too expensive for your life expectancy. This is something that must be considered, but these are calculations that are done from the healthcare system.
What's the durability of the product? Does it depend, for instance, on what's the durability of the product? And like if it depends, for instance, on previous conditions and on the bone itself?
The aging of the product.
Yeah, the durability, like does it have to be changed or so on?
Well, normally, considering the regulation, European regulation, you have to define life for your device, like every medical devices. The point, there are devices and devices. In case of implantable devices, you have, because of laws, to say an age, a maximum age. But in this case, what is the alternative? Is the revision surgery. So if you say these last 10 years, after 10 years, you should open a patient, explant an osteointegrated implant, wait until the bone is recovered, and implant a new one. Normally, if you go the risk and benefits, this kind of condition is every time avoid it. So life expectancy, I think we declare like 10 years, maybe less. But practically, if it still works, it stay there. This is just a number you have to declare because of rules. But nobody open a patient again, do again an intervention if the device that is osteointegrated is still working. So that's why. In case of revision, this is a good question because we can talk about revision. The commercial implants, like the first prototype we made, the Osteocustom, are more or less 15 centimeters long. This is quite long this is quite long for the use, also because the osteointegrated portion is the distal part. The other part is just probably useless. That's why we are working on the redefinition of the design. Osteocustom was made in length, copying the commercial stems. Doing some analysis, we considered the final portion useless and are working on a redesign that in which the length is halved, so 7 centimeters long, because you just need the osteointegrated portion working, the contact surface. The other is not in contact with the bone, so it's useless. These allow you, in case of revision surgery, to save more bone, because to explant an osteointegrated implant, so you have to cut the bone longitudinally until you overcome the stem. You open, like a book, the bone, and in some way that is not easy, try to extract the stem, the femoral stem. It's like Excalibur in the stone, so it's very hard. So there are some techniques, but it's better to avoid this step. Or to reduce the risk. In order to reduce the risk, in case of revision is necessary, you can have a short stem. Short stem means that this cut can be shorter and more bone is preserved. We are working in this direction. Even a joint, you see, it's quite long for the necessity we have with the thumb. So we are redesigning this fixture to be thicker and shorter. We do a research project, so we like to do stuff and change. At this stage, we're doing prototypes. So probably when we will start doing implantation with our devices, a joint, we did with a joint, but this was not a critical issue. With Osteocustom, probably we are planning to redesign with a shorter stem, like in hip arthroplasty. Arthroplasty started with the long femurs, and now the new femurs are very short, like this. So the new femoral stamp in case of internal endoprosthesis. So in order to have a bone preservation, it's better to reduce the quantity of bone to interact with.
Okay.
Any other question?
Yeah, another one. Is it really more beneficial this way, the osteointegrated? I mean, the normal type of prosthesis has a re-evaluation every 3 years, I think.
Depends.
It depends. Okay. So is it better if like a patient age and has osteoporosis and this type of implantation, is it better or not? I mean, for the fractures and everything else.
Well, if at the time osteoporosis is a, let's say, critical aspect of your bone quality. If at the time you come to us, you don't have osteoporosis, you are technically eligible. Probably the surgeon looks at the history of your family. So osteoporosis if your parents have some cases of osteoporosis, I don't know if they consider it eligible or not. This is something that the surgeon must decide. But consider that once you have an implanted fixture, in the bone, you have a mechanical stimulus of the bone. Osteoporosis, lots of the times arise or is accelerated, let's say, when you have no load through the bone. Unloaded bone tend to demineralize, and time over time it becomes weaker and fragile, and there's a scale osteopenia towards osteoporosis. With a load connection, you have a load stimulus, a mechanical stimulus of the bone that, let's say, favor an increase in the bone mineral density of the bone. Now, the counterpart is, that is a problem that we have with the normal arthroplasty, is the stress shielding effect. If the surgical intervention is not properly made, but this is just a matter of intervention, not the device itself, there's the risk that the load distribution where the implant is fixed can be compromised, or let's say not regularized. In case of not regular load distribution around the osteointegrated implants, you have a portion around the implant that are more loaded than others. So you have not a uniform distribution of the load with the spots of lower and higher bone mineral density. And this is risky because you can compromise the bone interface around the osteointegrated implants. So this is a matter of surgical technique, but this is another risk that osteointegrated implants have. So the excessive stimulus is, if with a good clinical intervention, allow you to get a, let's say, homogeneous bone mineral density. Excessive stimulus without a good surgical intervention over years can create problems. So there's always a combination of factors in my, we are not trying to put the socket type prosthesis in the bin. We have lots of projects also related to socket type prosthesis. Let's say that design now reached a high level of technology in terms of design. We can work on the materials. We have some project about materials, how to construct this socket type prosthesis. And we are working also on the design of this, on the design in terms of aesthetic, and also the manufacturing process. Now, Centro Protesi Inail produced socket type sockets manually with, let's say, they are handmade. This process require about, well, let's say, days for the production of a socket. We are now working with additive manufacturing to faster the process and produce a socket in less than 1 day. So we are trying to moving towards the direction of a reduction of timing for manufacturing of some of our components. There are some components that still require us experts, orthopedic technicians that manually produce the socket or the prosthesis. We are trying to collaborate with our manufacturing department to help them in try to reduce their effort, their working hour in those steps that can be replaced with additive manufacturing. Orthopedic technicians are fundamental for us, but it's better if they expand their expertise, their high expertise in complicated stuff. There are some parts of their work that is made of, consists in production of components that can be easily made also with additive manufacturing. So we are now collaborating with them, try to understand which are these part of their work that can be substituted with additive manufacturing, and collaborate and get a better collaboration so that they can focus on the complex part of the production of a prosthesis. So we are now we are pretty new. I started working at Centro Protesi 5 years ago with a not permanent contract, and then I went back again. I came back again less than 1 year ago. So our group is pretty new. We are 19 new resources of Centro Protesi Inail, stable resources, let's say. And now we are trying to collaborate with all the departments, from the rehabilitation guys, physiotherapists, medical doctor, and manufacturing department, in order to understand how research, despite our research project, how research can collaborate with them and facilitate some of the process they do every day. Another invitation, if there are any graduating students that want to do a thesis, master, bachelor thesis, PhD, experience, internship at Centro Protesi Inail, we do research, we normally collaborate with university, we can do collaboration contracts with public institutes principally, for having students coming to us, make an experience, make a thesis, make a project, and so on. So if anybody of you is interested in collaborating with us, we are open to, we can talk. Let's say we can talk. We are all youngs, 30. Grazie. Okay. Thank you for going deep with other topics. Come to the booth again. Sorry for I'm repeating. Come to the booth. Come to the booth. But if you come to the booth, you will see.